Let us study orbits of artificial satellite. All the orbits of satellites do not have similar orbits. Some are having, we can say that its nature itself will be different. That is, some of them will be circular, some of them will be ovoid. Even we can say that their height from the earth will be different. Some of them will be very far from the earth, some of them will be close to the earth, some of them will be in middle. Again we can say that the satellites which are sending from the earth, that is happening with the help of satellite launchers. Satellite launchers are rockets, we can say. In them they carry the satellites, and at which place it has to place, that work is doing by the satellite launchers. Now again, once it is fixing any part of the orbit, afterwards certain velocity is given to the satellite. With the same velocity it will revolve around the earth. Now all satellites won't revolve in the same way. Some of them, that means all won't have similar type of orbits. For example, imagine this is the earth, this is its center, this is the equator, these two are the poles of the earth. We can say that parallel to the equator, parallel to the poles, even certain angles around the earth, satellites are revolving. For example, just imagine this is the earth, this is its equator. We can say that such a way satellites can move. Now just imagine this is the pole, this is the pole, this way some satellites can move. Even we can say certain angles, like that also, certain angles also the satellites can move. So we can say that now around the equator I am drawing like this, such a way certain distance from the earth satellites are fixing and they are revolving. Or we can say around the poles at certain distance fixing the satellite, then they revolve like that. Or we can say certain angles from the surface of the earth, we can say that around the earth certain angles satellites are revolving. So we can say that they revolve around the earth through different orbits. All orbits are not same. Some of them parallel to the equator, some of them parallel to the poles, some of them revolving, we can say certain angles around the surface of the earth, we can say. Above the surface of the earth at certain angles, we can say. Suppose this is there, this is the exact pole, we can say, but this way also its movement is possible. Such a movement also possible. Correct parallel movement is possible. Parallel to the equator movement is possible. Parallel to the poles movement is possible. Like that way different satellites are having different types of movement for giving us more and more information about various things. Satellites, we can say that satellites change our life, we can say. So much changes globally. It is done so much help to us. Even now it is doing. So because of the help of satellites only we are getting all information about various parts of the world, even various parts of the earth. Now here we are going to study about, so different poles you understood, two poles of the earth, different orbits you studied through the poles or around the poles, around certain angles, even around the equator, the movement of the satellites you understood. Now just imagine this is the earth, this is its center. Now this is one of its orbit. Now for fixing a satellite on any one orbit, even its distance should be known to us, where it has to place it, even at which distance from the surface of the earth it has to place it. Full idea scientists are having, then they are sending it. Now, a satellite alone cannot move. Satellite, the carrying vehicle is there. That vehicle is known as satellite launcher. Satellite launcher is there. That means the vehicle, we can say spacecraft, we can say. The vehicle in which satellites carrying, and where it has to place already the mechanical device is there, the mechanical arrangement is there. So even we can say that electronic arrangement is there. So with the help of that all arrangements, they are fixing and making it in the satellite launcher. Afterwards they are sending the launcher from the earth. So in the launcher there will be satellite. Then with a certain velocity it has to move from the earth. Then only it can be able to cross escape velocity of the earth's atmosphere. Escape velocity also you people studied. So with a certain velocity, that means where it has to reach. So for reaching that certain distance from the earth itself, the initial velocity want to supply to the launcher. So we can say that this escape velocity is the initial velocity exerting by the launcher as and when it does its launching. That means initial movement, we can say that initial movement exerting by the launcher, that is known as escape velocity. With that velocity, if it moves, it can be able to cross Earth's atmosphere. Even crossing that distance, once Earth's atmosphere will move or cross, then we can say that we are reaching to the space. Again in the space itself, again at which distance it has to fix. So that distance keeping in the mind, scientists are giving to the launcher's escape velocity, a particular velocity with which it has to move it. Now here we are studying about, this is the radius of the earth, that is representing by capital R. Now from here towards here, just imagine here we people placed the satellite. So now from here till the orbit, how much distance is there or how much height is there, that we can represent by putting small h. The mass of this satellite we can represent by putting small m. Mass of the earth we can represent by putting capital M. Now from the center towards the orbit, how much distance is there, that we can say that radius of the orbit, that we can be able to represent by putting small r. Now here one satellite is now revolving. How it is revolving? First this launcher fixing the satellite on the orbit of the earth. Afterwards giving a certain velocity to the satellite. With that velocity the satellite can be able to revolve around the earth. The velocity which is supplied to the satellite, that is known as critical velocity. Critical velocity. That we can be able to represent by putting small v c. Small vc. That is critical velocity. The velocity which is giving to the satellite, then with that velocity the satellite can be able to revolve around the earth. Now here we need to derive the critical velocity of satellite. Which satellite we are sending, its critical velocity we need to find out. Why? Because here suppose near the surface of the earth, that is also we can say that above 100 km from the surface of the earth, we can say that we can be able to place the satellite. Then again we can say that is minimum distance of fixing the satellite is 1 180 kilometer, then 2. We can say that so much far. So we can say that here now minimum at least 180 kilometer far from the surface of the earth only up till now fixed through the satellite. So we can say that this is 180. Again we can say that beyond 35,780 kilometers also. So we can say that starting from 180 kilometer beyond the earth's surface, again we can say even far from 35,780 kilometers also different satellites we fixed. Now we have to derive critical velocity. Why to derive critical velocity? Because all satellites are not moving with the same velocity. Why? Because all satellites are not revolving around the satellite with the similar or through the similar orbits. Some of them moving around the satellites, some of them moving around the poles. Even we can say certain angles that we had already studied. Even we can say their distance from the surface of the earth is not same. Then, which all satellites are fixing on the surface of, on the orbit of the earth, to them giving critical velocity by the help of launchers. At which distance placing the satellite, depending upon that, its critical velocity will be different. We can say that they may be at least we can say 180 kilometer far from the surface of the earth. Then we can say that even it can be more than 35,780 kilometers from the surface of the earth. So such a far away or such a heighted condition from the surface of the earth satellites are fixing. Then depending upon their position as well as height from the surface of the earth, their velocity, their critical velocity also will be different. Now for deriving or for finding what will be the critical velocity of different satellites, we have to derive a formula. Now for deriving that, we will take the help of centripetal force exerted by the earth as between earth as well as satellite. Then even we can say gravitational force between earth as well as satellite. We will relate that. So let us see now centripetal force between we can say central part of the earth as well as satellite. Now this centripetal force means what? Center seeking force. The earth pulls the object which are moving around it towards it, or which are above the surface of the earth towards it. So the pulling force exerting by the earth on any object, that we can say is centripetal force. That is equal to gravitational force between earth and satellite. Now centripetal force is equal to mv square upon small r. This v means critical velocity. Because of that, mv square upon r. Now this r we can write as small r is equal to capital R plus small h. Capital R means radius of the earth. Small h means from the surface of the earth towards the satellite, how much distance is there. That height is mentioned as small h. Now centripetal force we can write in such a way now. mvc square upon capital R plus small h, that is equal to gravitational force between earth and satellite we can write as capital G capital M into small m upon capital R plus small h whole square. Now we will do the cross multiplication. So mvc square into r plus h whole square, that is equal to r plus h, we'll put inside the bracket, then g capital M small m. Now we will keep mvc square left side, we will send this part to the right side. Capital R small h into capital G capital M small m upon capital R plus capital H whole square. Now this square and this value we can cancel it. Then mvc square, that is equal to capital G capital M small m upon capital R plus small h. Now we will keep left side vc square, then m we will send it to other side. So we can write as capital G capital M small m upon capital R plus small h inside the bracket into small m. Now this m and this m we can cancel it. Then vc square, that is equal to capital G capital M upon capital R plus small h. Now from this vc is equal to square root of capital G capital M upon capital R plus small h. Using this formula we can be able to find out the critical velocity of each and every satellites which are moving around the earth. Satellites are helping for doing different functions. The functions of the satellites decide depending upon the height from the surface of the earth where it is placed. So we can say that the functions of the satellites depends on the height at which it is placed. Then second thing we can say that the nature of the orbit through which it revolves can be circular orbit or can be ovoid or elliptical orbit. So depending upon the types of the orbit, we can say that the functions of the satellite will be different. Then other thing we can say that one more important thing is there, whether the satellite is revolving parallel to the equator or parallel to the pole, or we can say that at any angle around the surface of the earth. Depending upon that, again the functions of the satellite will be different. So we can say that functions of the satellite depending upon three different factors. First thing we can say that is the height of the satellite from the surface of the earth. Second thing we can say that nature of the orbit. Third thing we can say that whether the orbit is parallel to the equator or parallel to the pole, or we can say at any angle around the surface of the earth. Now we can say that critical velocity, we had already studied critical velocity formula also we had studied, that is Vc, that is equal to square root of capital G capital M upon capital R plus small h. This formula we had already studied. So from this formula itself we can understand that critical velocity of the satellite does not depend on the mass of the satellite. It depends on gravitational constant, mass of the earth, then radius of the earth, as well as we can say that height of the satellite from the surface of the earth. It does not depend on the mass of the satellite. Now we can be able to understand that one more important thing, how much height, how much far and far from the surface of the earth, or how much more and more heighted condition if the orbit is there from the surface of the earth, then its critical velocity will decrease. If the satellite is near the surface of the earth, its critical velocity will be more. At the same time, if it is so much far from the surface of the earth, its critical velocity will be less. Now, depending upon the height of the orbit around the surface of the earth, we can classify the orbit of the earth into three categories. They are, we can say that high earth orbit, we can say that high earth orbit satellite also. Now when we classify the orbit, the first one, a high earth orbit, Second one we can say as medium Earth orbit satellite as well as medium Earth orbit. Third one we can say as low Earth orbit, and if satellite is there then we can say as low Earth orbit satellite. So we can say that satellites are revolving around three types of orbits. We can say high Earth orbit, medium Earth orbit, and we can say that low Earth orbit. Now high Earth orbit, its distance from the surface of the Earth will be more than 35,780 kilometers. Medium Earth orbit, its height will be between 2000 kilometers from the surface of the Earth to 35,780 kilometers. And low Earth orbit height will be between 180 kilometers from the surface of the Earth to 2000 kilometers. So, seeing this we can understand that how much heighted condition different types of satellites are fixed on different orbits. This all fixing work as well as taking them to the correct orbits and placing them, all these things are doing with the help of launching vehicles, or we can say as satellite launchers. Launching vehicles, or we can say as satellite launchers. With the help of them, taking the satellite to the respective places and fixing them, even to them giving critical velocity. Once it is getting critical velocity, then only that satellite can be able to move from one place to another, or we can say revolve around the Earth's orbit. Now we will study in detail about high Earth orbit, medium Earth orbit as well as low Earth orbit. High Earth orbits takes 24 hours for revolving around the Earth. Then high Earth orbit's speciality, it is moving around the equator. As a result of it, we can say that it is moving parallel to the Earth's surface, we can say. So we can say that suppose the surface of the Earth is like that, then parallel to the surface of the Earth, the movement of the high Earth orbit satellite will be there. As a result of it, we can say that the movement of the Earth also will be parallel to the high Earth orbit satellite. As a result of it, we can say that from the Earth, when we look at the high Earth orbit satellite, we feel that it is stationary. Why? Because it has same movement as the Earth. As a result of it, we can say that it takes 24 hours for completing one revolution around the Earth. Second thing, we can say that from this type of satellite, most of the area of the equator can be able to visible. As a result of it, we can say that for various purposes, this type of satellites are helping. Why? Because from so far it is catching all information about the surface of the Earth. Plus it is so far, as a result of it, it can be able to see so much area, very large area of the surface of the Earth. Now, we can say that here, the movement of the satellite, high Earth orbit satellite is parallel to the surface of the Earth, and we can say that it is revolving around the equator. Now, we can say that from the Earth, when we look at it, we feel that it does not have any movement. It is stationary. Because of that, it has got the name as geosynchronous satellite, or we can say as geostationary satellite. Now we can say that even they are helping for broadcasting. We can say that broadcasting TV programs, then we can say that internet functions, even radio functions, radio's broadcasting work, even we can say that carrying signals for broadcasting TV, radio, etc. Even we can say that for understanding the atmospheric situations, we can say that whether any calamity is going to occur, that means any flood, then storm, cyclone, such things are going to occur, or for understanding the atmospheric situation, temperature, or for forecasting the atmospheric weather situations. For that all means we can use high Earth orbit satellites. Now other thing, medium Earth orbit satellite, it takes 24 hours for revolving once around the Earth's surface. Second thing, we can say that they are detecting the actual position of which thing we wanted to know. So correct position can be able to find out with the help of medium Earth orbit satellite. We can say that positioning satellite. Now here we can say 20,200 kilometer far from the surface of the Earth, GPS is fixed and kept. GPS, its full name is Global Positioning Satellite. It is giving us accurate position of the things what we need to find out. We can say that the position means enemy's weapons where it is kept. Second thing, we can say that where the various forests are there, the actual position of different forests, actual position of oceans, then which all information, even we can say natural resources, where it is, where large quantities of natural resources like gold mines, then other mines, even we can say petroleum resources, then fossils, even we can say that natural gas, where it is present. For detecting that we can use, or for finding that we can use medium Earth orbit satellites. Then the other one, that is low Earth orbit satellite. This low Earth orbit satellite takes only 90 minutes for revolving once around the surface of the Earth. We already studied at which distance it is fixed. So only 180 kilometer to 2000 kilometer from the surface of the Earth, within that range they are fixed, and they are helping for scientific experiments, even for understanding the atmosphere, even any natural calamities are going to occur. For such and such purposes, we people are using low Earth orbit satellites. Now, here we can say that low Earth orbit satellites, there two examples we are having. One is Hubble telescope, the other one is International Space Station. International Space Station is one type of satellite, Hubble telescope is other type of satellite. They are all fixed at a low Earth orbit or on the low Earth orbit. What are satellite launch vehicles? Satellite launch vehicles are vehicles which carry satellite to the respective orbits of the Earth. Now, we people already studied about Earth's orbit. At present, we can say more than thousands of satellites already fixed on Earth's different orbits. For carrying satellites from the Earth, we are using satellite launching vehicles. India's satellite launching vehicle at present we are using, that is PSLV, Polar Satellite Launching Vehicle. Before, we were having other type of launching vehicle. In that only two stages were there. But at present in PSLV has 4 stages. Each stage it carries fuels. Now, why PSLV? That means different stages are arranged in the PSLV, because one tank, in that how much fuel is there, its use is getting over. That tank will discard from the main body of the satellite main body of the launching vehicle and it will fall down. As a result of it, the weight of the launching vehicle can be reduced as and when it moves higher and higher. Now, launching vehicles are carrying very heavy satellites. Even launching vehicles' weight is very high. Why? Because it needs to carry so much fuels with it. We can say that maximum weight of the launching vehicle is its fuel itself. Now, PSLV is having such a arrangement. This is the base part. Here we can say that engines arrangement is there. Here this base part is having engines arrangement. Here first stage is there. Here we can say solid fuel is arranged. Inside the first stage, this is the first stage I am saying you. In the first stage, solid fuel is filled and kept. Remaining means different types of fuels are there, but in the first stage, solid fuel is kept. In the first, as and when it begins its launching, that time, this first stage, solid fuel started to burn. As a result of it, large quantities of smoke will come out through the nozzles which are made at the rear end. Rear end means it's opposite end we can say, or it's bottom part. There so much holes are there. Through that hole we can say that large quantities of smoke will come out. That will push the launching vehicle to the upward direction. We can say that the working of PSLV or launching vehicle is based on Newton's third law of motion. Newton's third law of motion. What is Newton's third law of motion? For every action, there will be equal and opposite reaction. So here we can say that here action of burning. As a result of it, smoke is coming out. That smoke is doing the reaction of pushing the launching vehicle towards upward direction. So as a result of it, we can say that its movement will be straight upward direction from the surface of the earth. Once the burning of fuel in the first stage will complete, what will happen? This fuel tank as well as the engine will discard from the main body of this launching vehicle. As a result of it, we can say that this part will separate out and it will fall to the earth. We can say that it will fall either on the ocean or we can say that any unpopulated land. So that remote control will be doing from scientists, or we can say this satellite mission centers. From there it's a remote control system will be there. As a result of it, making this fuel tank as well as the engine which is connected to the first stage will discard from the main body, will fall on the earth itself. Why? Because before crossing the earth atmosphere itself, this fuel will burn and finish. Then its function finish. Then it will fall down. After that, here again we can say that once its burning process will over, then it can be this second stage will start to ignite. It will start to burn. Then again smoke will come from there. It will push the launching vehicle further upward direction. As a result of it, one stage gets over, again that tank will discard. As a result of it, we can say that finally when it is reaching on the orbit of the earth, there means the weight of the satellite launching vehicle will be less. If more weight will be there, movement will be a bit difficult. But due to this process, the movement of the launching vehicle can be done easily as well as in a very quick way. Now PSLV is the India's new satellite launching vehicle. PSLV. Its full name is Polar Satellite launching vehicle. Now, one drawback is there. We can use a satellite launching vehicle only once. Because of that, the making of satellite as well as launching vehicle is costs very high. Why? Because once if we are using it, further we cannot be able to use. Why? Each and every part will be discarded. Once the discarding process is happening in the space, then that cannot fall into the earth. It will remain in the space itself. So here we can say that once we are sending a launching vehicle, that cannot return to the same place again. So we can say that again, next time when we want to send another satellite, again we have to make other launching vehicle. For that, its cost is very high. Then, because of that, USA made now one reusable, we can say, reusable launching vehicle. Its name is Space Shuttle. Because of the help of Space Shuttle, we can say that same process as and when we sent Space Shuttle to the space, that particular time again its fuel tank will discard from it once its use gets over. But some part which is carrying the satellite to the orbit, that thing again can come back to the earth. So some parts discarding will happen, but at the same time main body will not discard. It can be able to come back to the earth again. So because of that, we can say that little bit cost of production of satellite launching vehicle can be reduced. This satellite launching vehicle, that is Space Shuttle, produced or made in USA. As a result of it, they are using it again and again. But in India, PSLV, once we use, its function gets over, we have it is already discarding, then new we have to make it. PSLV is the launching vehicle's name, but in that name many launching vehicles are there. Now we people already know about the satellites. Now satellites are useful for various purposes. As a result of it, we can say that our life became far better. We are getting all informations about each and every part of the world, even about the celestial body, with the help of satellites. In the previous class, you people studied about telescope. Telescope also having such a function like can be able to give us information about faraway objects from the Earth's surface. We can say that it gives us information about planets, different types of planets, stars, etc. Now, in this chapter we had studied about the satellite. We can say that it gives us so much information about solar system. Even we can say that its origin as well as evolution. Now we can say that the satellites which is placing on the Earth's orbit, that is carrying with the help of satellite launching vehicles. Now, as and when launch the satellite launching vehicle, it requires very high velocity that needs to cross Earth's gravitational pull. We can say that it needs to cross Earth's atmosphere and it has to reach into the space, even we can say far from that. So with such a velocity, we can say that such a initial velocity, we have to send the satellite launching vehicle. Now we can say that the velocity with which we send the satellite launching vehicle, that is known as escape velocity. Escape velocity. Now, escape velocity we can write as VESC, escape velocity. For finding this escape velocity, we have to use one formula, that is square root of G m upon capital R. 2 into G means gravitational constant into mass of the earth upon radius of the earth. So as a result of it, we can say that the satellite launching vehicle, just for crossing its escape velocity, it needs escape velocity of 11.18 kilometer per second. Now escape velocity, its other word we can say initial velocity. At this velocity, the launching vehicle should move from the earth, then only, that is 11.18 kilometer per second, or we can say as 11.2 kilometer per second. In 1 second, if it can cross this much kilometer, then only our satellite launching vehicle can be able to cross escape velocity. Now, the launching vehicles, if it has this much velocity, then only it can be able to cross Earth's gravitational pull, or we can say Earth's atmosphere. But beyond that, it needs to travel many kilometers. Because of that, its escape velocity should be very, very large. Now, we will study about various missions done by the scientists for sending as well as orbiting satellites on the orbit of Earth as well as on the orbit of Moon, even we can say on the orbit of other planets. So here first we will study for orbiting satellite on the Moon, even we can say on the Mars. Scientists sent many satellites. As a result of it, these satellites could collect more information about the Moon, about the Mars, even about the other planets. We can say that Moon is very close to the Earth because it is the satellite of the Earth. Mars is just next to Earth. Even then, because of the help of that, we could be able to understand more about Mars. Even satellites are trying their level best to go to other planets. Even they are trying to understand each and everything. We can say that their gravity, their density, even radiations, whether water is available, whether soil is there, whether rock is there on their surface. For understanding each and every detail, these satellites are sending to different, we can say that different satellites. We can say that different satellite means only to the Earth's satellite, that is to the Moon we can say, even Mars, other planets, etc. Because of the help of that, we could collect many information about the solar system. Now, as and when they send the satellite, or we can say spacecraft, in that only they are carrying the satellites. With the help of them, even they could be able to collect soil, rock, even dust particles from different space centers we can say. Like we can say from the Moon, from the Mars, even from different planets. As a result of it, scientists could be able to get more and more information about the Sun, then different planets, then Moon, even we can say more detail about the origin as well as evolution of solar system. India has done so much progress in the field of space technology. We can say that India made different types of spacecraft or space vehicles, or we can say that satellite launching vehicles. In that, we can say that even 2500 kilogram mass is there, weight is there, such as satellites they used to carry. Now, many such satellite launching vehicles made by India. Out of them, most important satellite launching vehicles are PSLV and GSLV. PSLV and GSLV. We can say as Polar Satellite Launching Vehicle, Geo Satellite Launching Vehicle. This is made by India. Even many other, but out of them, these two are most important satellite carrying vehicles. Now, even many, we can say large number of satellites are also made by India. Out of them, we can say that different series of satellites, INSAT series, GSAT or GSAT series, INSAT series, or we can say as INSAT series, GSAT series or GSAT series. Series means the number of GSAT satellites, number of INSAT satellites. Now here, EduSat, number of EduSat satellites, then number of IRS satellites, number of IRNSS satellites. Like that way, number of satellites already placed on the orbit of the Earth. Even we can say that on the orbit of the Moon, then even Mars, even other planets we can say. Now, for what purpose they are sending these satellites to the Earth's orbit, Moon's orbit, Mars orbit, or even other planets orbit? We can say that now, here few examples I given, their functions we will study, then we will come to know what may be the function of even other satellites which are sending to different missions, or different satellites which we are sending to different places like Moon, Earth's orbit, Moon's orbit, Mars orbit, even other planets orbit. So we'll see now for what purpose these satellites are helping. That is INSAT as well as GSAT. These satellites are helping for collecting information as well as giving help for telecommunication work. Telecommunication means we can say that telephone, mobile, its all functions it is helping. Then other thing, TV broadcasting, programs, TV programs happening in the TV. We can say that all programs are coming in the TV. That is because of the help of, we can say that, INSAT as well as GSAT satellites. Other thing we can say that for understanding all informations about the atmosphere, we can say that whether any calamity is going to occur, that means any flood, then we can say that any earthquake, cyclones, storms, any such problems are going to get to the Earth or get to India or any other part of the world. For understanding also it is helping. Now we can say that EduSat. EduSat satellites are working for giving more and more education information to us. We can say that EduSat satellites working for or working in the field of education. Then we can say that IRS series of satellites, that is giving us information about where natural resources are present. Natural resources like different types of metallic minerals. Then we can say that petroleum. Then we can say that coal. Then fossils, natural gas. It's all deposit where. For understanding that, this IRS series of satellites are helping. Even it is helping for disaster management. Any problems are getting to the world. Any disaster is getting to the world. So from people will come to know beforehand. It is going to happen with the help of satellites. Then it should not affect us for protecting us from various calamities. These IRS satellites are helping. Now IRNSS satellite series, that is helping us for detecting any locality or any location we can say, or any part of the world which we need to find out. Even we can say direction. Even we can say that now enemies in the war, the enemies which all weapons they are having. These all things are detecting work. Even we can say that some, suppose any accident is occurring in remote areas. So there means where that accident occurred, then which all parts are there, or the parts of the vehicles, or any, what we can say, so much war is occurring, that particular time, actual place of the war, then which all harmful effect happened as a result of war, or as a result of accidents, we can say air crash we can say. So where it is happened, actual place want to detect. For that IRNSS satellite series is helping. Now we will study space debris. Space debris. Debris means what? Debris means waste products, waste materials. Here we are studying about space debris. So we can say that the waste products which are there in the space. Now, how waste products are forming in the space? One thing we can say that so many satellites we already placed on the orbit of Earth, Moon, then we can say Mars, even different planets. So as a result of it, we can say that how much satellites we placed it, all are not in working condition. Some are not in working condition. So we can say that they are non-functional satellites. Non-functional satellites, problem what is there? They cannot use for any function or any work. Non-functional satellites are useless now. It is remaining in the space. So that is acting like a debris. Second thing we can say that as and when we send the spacecraft or satellite launching vehicle into the space, stage by stage its parts are discarding out. The discarded pieces of the fuel tank, we can say, even we can say that engines, no use is there, such a type of engines, even its other parts which is not useful to the launching machine or launching vehicle, that is falling into the space, then that will be there in the space. So we can say that that has no function further. So that is also acting as a space debris. Then at present, more than 2 crores of pieces of, so we can say that at present more than 2 crores of pieces of debris is there in the space. Now these pieces said minimum size of this piece, means large piece also will be there, but at least minimum size of the space debris, minimum length of the space debris will be more than 1 centimeter, we can say. More than 1 centimeter length will be there to the minimum size of the space debris. Now these space debris, more than 2 crores of pieces are there. So you can imagine that will be moving here and there in the space. That may even hit on the satellite. As a result of it, damage getting chances are there to the satellite. Even we can say that satellite launching vehicles. So as a result of it, so much problems may occur to the satellite, even satellite launching vehicles. So here now what scientists are doing, they are trying to discard or remove all these debris in the near future. If it cannot be able to remove from the space, then in future we even cannot be able to place the satellites on the orbits of Earth, even Moon or Mars, etc. So we can, from this we can understand how much dangerous are these space debris. Let us hope that scientists will be getting more idea. Even they are trying to do many experiments for removing it. So we will hope now in near future anyhow they will be able to remove all these waste products, waste materials from the space. Thank you.